May the 14th, 2025. Guys, you're looking at images this morning of our sun, and the sunspot on the left that's turning around facing us now has become quite active. We had a couple of X flares already, a very strong M flare. The one on the right is the one that we watched very carefully. It was so large, it had all the ingredients for an X flare, and it sat there very quietly until it got around that edge. But right now, things are really picking up with a flare on the left. You see that? We're going to take a look at it. Now, they finally put a tracking model up for the flare that we saw yesterday on the right side of the sun, but we haven't seen anything yet as far as tracking for this energy here. Now, these flares, again, you've got two types of energies, proton and photon. The photon is light speed, 8.2 minutes. We feel that. You get some radio blackouts in the upper atmosphere, things like that. And then if they throw the CME out, that takes a couple of days for that proton density cloud, which is basically plasma, to get to our planet if it's Earth facing. Now, let's go back 2 days on this particular camera, SDO. Also, it'll start with the filament release in the top. Let's play this forward. Check that out, and you see the Hyder flare from the resulting collapse of the remaining energy. There's your flare there, but watch right here what's coming around towards us. Bam. Can let it go back through one more time. 13th, going into today. Watch these filaments in the next few days here. You saw what happened right there, right? You also have a couple here. Right there, though, that thing, it needs to go ahead and get a lot of that energy out. Well, it's not Earth facing. Let's look at the information on solar ham, guys. This was the X1 plus flare yesterday, but this 2.7 was right here. These are very strong M flares. This one almost reached the X flare line, which is the red line. And notice that the X flare chance yesterday was 0.05%, I think it was. It's 30% now for today. Proton events, 50%. That's very strong for those. C flares, 99%. And M flares, again, which can be very strong, 75% chance of that happening today. This particular sunspot has come around firing, and it is not shooting blanks, guys. Now, they're calling it 4087, and it's dual polarity. You can see the red and orange areas to the left, and then the blue section here, that's plus and minus. And that's, again, not nearly as large as the sunspot that we just saw pass across the face of the sun, but it's more intense already as far as the energy that it's releasing. And if you look at the radio blackout area over the Atlantic, guys, it was very wide. It's called the D region absorption prediction, or DRAP. And that's what happens. Again, and it takes it 8.2 minutes to travel 93 million miles. That's the speed of light. And there's actually technology that they're looking at that's faster than that. They're saying that AR-487 is now the focus of attention, with an M5.3 and an X2.7 solar flares detected so far on Wednesday. There's actually been about 4 flares there. This was a little earlier than the film we just saw. It says the first event, the M53, was associated with a fairly faint easterly directed CME. The second and much brighter X2.7 event so far appears not to be very eruptive. There's not a tracking on it yet. We'll take a look at that, but it says what also has my attention, this is the author here in this article, is what's taking place behind the sun's east limb. At least 2 eruptions of plasma were observed, the first at 1:55 UTC and the second at 07:45 UTC today. We may have another active spot region to watch for within the next several days. Again, it's not going to take long. You saw how fast this sunspot came around. So it looks like we're about to go into a week or so of very active sunspot activity. Now, I mentioned in the last video yesterday that they had not put up any tracking of that large CME that was created by the first X flare yesterday, the 1.2 I think it was. But they do have that model now. What you're looking at is the sun's in the center, the Earth is in the yellow dot. All of that's marked up here, guys. See this? The Earth in yellow, Mars in red, Mercury in the orange, Venus in green. And so it doesn't look like we're going to see much of effect of it, except that initial blast. If you can see an X flare, no matter how close to the edge it is of the sun, if you see it, it's like a light bulb. You're going to get a photon blast from it, just not as strong as you would see if you were, say, sitting right here where Mercury just passed. Right there, Mercury just took a lick from this thing. Anyway, that's what would have happened. That's what we were hoping would not happen while that sunspot was on this side of the sun facing the Earth right there. We were very fortunate. A lot of people were praying for this thing to pass on by. It did. Now we're going to have to deal with another one. Now, one thing that I want to say, we talked about the Earth and the sun's magnetic connectivity point. And sometimes when a sunspot or a filament gets close to that point and it senses that energy transfer between the sun and our planet, which happens every 8.2 minutes, by the way, it will cause the flare to either ignite and explode or the filament to release. And I don't know if that's what happened, but what we are seeing is that Venus and Mercury are on this side of the sun. See that? And they have magnetic connectivity points. Mercury right there, which once was known, guys, as Comet Mercury, came very close to the Earth, made a couple of loops, went back out closer to the sun. They thought it was a comet. It could have been. Anyway, that may be what's triggering the events here. But over here, what's triggering the events on this side that we're seeing now? Not much out there. You've got Mars sitting pretty far out right there. But again, it's a strong planet. It's like Earth. It has a gravitational pull. It has a magnetic connectivity point. And you can kind of see it with these what they call the IMF lines, or the 3D IMF lines here. That's practically showing you the connection points. Look at this. And so when you see Mercury get this close and this flare comes out, then is the same thing happening now with the connectivity point of Mars right there. We'll have to see. It's all a new science. They don't talk about that a whole lot, but it's interesting and it's obvious. Now let's take a look at LASCO C3. Remember, these images don't come in quite as fast as the ones we see on the SDO. And so there's a delay, and we're not seeing the last few flares from this morning. What you will see is that's the filament release yesterday. Here's the first X flare, and then you're going to see a backside burst in the first burst of that sunspot that's coming around now, right there. Notice the closest stars to our sun are appearing in the left corner right there. They call them the Pleiades, or seven sisters. There they come right there. Again, those stars you see, that is the closest star group to this star right there that we call our sun. Now, even though we haven't seen the solar wind really kick up that much, again, the photon blast, we felt that. This is from the ACE satellite right there, close to Discovery. It gives us the same information. Discovery is just an updated version of ACE, basically. But look at the interruption in the protons again, right there. Check that out. Right here in the middle of the 14th. This is the 15th. You can see it. So again, you see the radio blackouts. You can see more radiation pouring in. Again, they're expecting an S1 radiation storm today. And even though that proton flux chart, and it gives you different energy levels, your low-level protons, your high-level energy, and all of that. There's another chart that matters. We don't talk about it that much. But you notice this red dotted line that comes across here? It's called the threshold warning as far as proton flux. And this is how close, this is where it normally cruises around here, right there. See that? But this is what it's doing now. And it almost got to this warning threshold. See that? It's starting to come back now. But we're just now getting into the area where that solar spot and that group, one behind it, is coming around Earth facing, which is also is the energy that's sensed by these satellites. Again, the closer it turns around towards the planet. Now, this chart really matches the X-ray flux chart very closely, but it's called the proton flux chart. And what it's doing is picking up the energy from those X-flares. See this? And this red dotted line is what's called the 10 EMV warning threshold line. Notice the numbers. It says 10-1, 10-2, 10-3. When it reaches 1, we are in an S1 radiation storm. Reaches 2, we're in an S2. That's what that's looking at. And this all started on May the 2nd. This is the average line. And now that we're getting those sunspot, or it looks like 2 of them, a sunspot group, this is what we're seeing. So this is how close we came to, so far, that S1 radiation storm warning. And what this does, it puts out a warning if it's expected or if it's expected to be prolonged. And you see this, if it was above that line, it would be it would be a prolonged warning. But this is giving you an idea, and this much activity is happening. And it's going down now, but it possibly could go right back up with those sunspots turning around or facing. The CERN this morning's been running very hot with peaks rising up and down like we've seen the last few days. Now this is again live right there, 1729. That is UTC time today. It's counting down. It is 10:17 Central Time, so they are 7 hours ahead of us, 6 hours ahead of the East Coast. Look at these two beams, very close. They're trying to get them lined up. And they're starting to do it. You just saw an expansion, and from this beam, we're watching live, and then this is the calibration showing you how close that they're dealing with. You've got your elevation, and you've got your windage on both sides here. Look at that, some of the closest we've seen. And this beam is starting to feel the closeness of beam 2, and that's where the energy expansions are going to come in. They're trying to get as hot as they can. They've got that new coating on the plates, keeping the cryogenics cool enough where they can maintain levels. And I think they're testing for everything they can. It's kind of like watching Dr. Frankenstein keep hitting that switch with the lightning coming down, trying to activate the monster. But these are very close together right now. Now, again, you're looking at it live. Here's your timestamp right there. Again, 10:19. That would be 11:19 on the East Coast. And here's your power line, the beam in black, but it's a combo of the red and blue. And now they're rising, and that's what we're seeing, guys. We just saw how close they are to hitting. Look at this. They're above 6.5 tera-electron volts now, which totals 13, which has been the peak. Now we're seeing it go higher than that. They could reach 14, which, guys, that's a lot of energy. But even though they're colliding, the power has not kicked in here yet. They haven't kind of linked everything together. They're doing what's called the BSRT calibration field. But let's take a look at cryogenics and see how they're holding up. And again, everything's green to go. As soon as they want it kicked in, it will be ready. And again, it's the smoothest I've ever seen it continuously. Normally, if you see the line go down, that black power line, something up here, one of these several sections has turned red, and you'll see the color. Each one is assigned a different color, too, when they go red. And this line at 2 degrees Kelvin is, the temperature of outer space. But you'll start to see a lot of different color lines start to kind of do a sine wave thing here. But the new coating on their plates has really worked for them, and that is not good for our magnetopause. And if we take a look at the magnetopause, you can see it's been pretty calm. The last few frames going in today as we play it forward, are the last few frames, guys. You can tell the energy is building up from those flares. Again, not as strong as what we've seen it. You see a little pressure there building up, and it's like squeezing a balloon. As the sun, energy of the sun hits our Earth and it compresses it. Then when you have the pressure back off, it expands back out. It's a plasma field. You have you have a plasma sphere as part of this whole design, as a matter of fact. But coming up, you'll see it starts to pick up the photon burst of right in here. See that? And so that's what's going to be happening now. It looks like for the next few days, as this intensifies and builds up, we'll see if it gets to an S1 radiation storm, and very well could get into another G1 or stronger geomagnetic storm. But guys, we're watching this. You watch it. It's a heads up. Be safe.